dear students. Glad to meet you again in this session. In this session 1.13, we are going to discuss about types of redox reaction from chapter 1, some basic concepts of chemistry in grade 11. In session 1.1, we have discussed about some importance of chemistry, nature of matter and its classification. In session 1.2, we have discussed the 7 basic units of SI system. In session 1.3, we have discussed the physical quantitative properties of matter. In session 1.4, we have discussed the uncertainty in measurement. In session 1.5, we have discussed the laws of chemical combination. In session 1.6, we have discussed the postulates of Dalton's atomic theory, atomic mass, molecular mass, and formula mass. In session 1.7, we discussed mole concept, Avogadro number, molar mass, and molar volume. In session 1.8, we have discussed gram equivalent mass for oxidizing and reducing agent and for acids and base. In session 1.9, we discussed the molecular and empirical formula. In session 1.10, we discussed stoichiometry and its calculations. In session 1.11, we have discussed the reactions in solutions. In session 1.12, we have discussed the classical concept and electronic concept of redox reactions, and we have discussed how to compute the oxidation number of an element. Learning outcomes. Students, at the end of this session 1.13, you will be able to list the types of redox reaction and explain the classification of redox reaction. There are 5 types of redox reactions. They are combination reaction, decomposition reactions, displacement reactions, disproportionation reaction, and competitive electron transfer reaction. We will see all these reactions one by one in detail in this session. Combination reaction. Redox reactions in which two substances combine to form a single compound are called combination reaction. Here we have taken two substances. One is carbon and another is oxygen. This carbon and oxygen combines to form a single compound called carbon dioxide. In this combination reaction, the reactant must be in the elemental form. The word decomposition means breaking down. Now let us see the decomposition reaction. Redox reaction in which compounds break down into two or more components are called decomposition reaction. A decomposition reaction are just the reverse of the combination reaction. And in this decomposition reaction, at least one of the product should be in the elemental state. Here we have taken potassium chloride. Potassium chloride decomposes into potassium chloride and oxygen molecule, and oxygen here is in the elemental state. In this decomposition reactions, the oxidation number of different element in the same substance is changed. Here we have taken potassium chloride. What are all the different elements present in the same substance? Potassium chloride, potassium, chlorine and oxygen. In this reaction, the oxidation number of different element, that is chlorine, change from +5 to -1. And when you note down the oxidation number of oxygen, it changes from -2 to 0. So in this reaction, the oxidation number of different element in the same substance is changed. But here there is no change in the oxidation of potassium in potassium chlorate. Let us see how to find out the oxidation number of an element in a compound having 3 elements. For this, we have to separate all the 3 elements, and the first element in the compound will have a positive charge, and the last element in the compound will have a negative charge, and the in-between elements will have a positive charge. Let us assume the oxidation number of chlorine as X. Now, we know that the oxidation state of all the alkali metal is +1. So the oxidation state of potassium is +1 plus X plus we have 3 oxygen atoms. So 3 into -2, which is the oxidation number of oxygen, is equal to 0, because we know that the algebraic sum of the oxidation state of all the atoms in a compound is equal to 0. So 1 plus X minus 2 into 3 minus 6 equal to 0, which gives the value of X as +5. And this is the oxidation number of chlorine in potassium chlorate. Now let us calculate the oxidation number of chlorine in potassium chloride. Let us assume the oxidation number of chlorine as X, and we know that the alkaline metal potassium will have the oxidation state +1. So +1 plus X equal to 0 because the algebraic sum of all the atoms in a molecule equal to 0. This gives the value X is equal to -1. So the oxidation number of chlorine is -1. Thus, the oxidation number of different element here is chlorine in the same substance changes from +5 to -1. Displacement reaction. Displacement means replacement. Redox reactions in which an ion or an atom in a compound is replaced by an ion or atom of another element are called displacement reactions. Here we have taken the reaction between copper sulfate and zinc. The another element that we have taken here is zinc. Here zinc displaces copper from copper sulfate and forms zinc sulfate solution. Here you could see a beaker containing a blue color solution which is nothing but copper sulfate solution. Place a zinc strip, metal strip in this beaker. After some time, this blue color solution disappears. This you could see in this picture. This indicates zinc displaces copper from copper sulfate and forms zinc sulfate solution. You could see a brown deposit on the metal strip, and this indicates copper gets deposited on this metal strip. Here, the metal causing displacement, in our case it is zinc, is a better reducing agent than the one which gets deposited, that is copper in our case. In other words, we could say noble metals gets deposited on a base metal. So this metal displacement reaction find its application in metallurgical process. Now let us see non-metal displacement reaction. In these reactions, a metal or non-metal displaces a non-metal from its compound. In most of these reactions, the metal displaces is hydrogen. However, in some reactions, oxygen or halogens get replaced. Here we have taken the reaction between zinc and hydrochloric acid. Here zinc, that is the metal, displaces hydrogen, that is a non-metal, from hydrochloric acid, and it gives zinc chloride and hydrogen. Disproportionation reaction. Disproportionation reaction is a special type of redox reaction. In some redox reactions, the same compound can undergo both oxidation and reduction. That is, an element in one oxidation state is simultaneously oxidized and reduced. Decomposition of hydrogen peroxide is a good example. Here in this reaction, oxygen element experience disproportionation. Here, oxygen of peroxide, which is present in -1 oxidation state, is converted to 0 in oxygen molecule, and it decreases to -2 in water molecule. So here the same compound can simultaneously undergo both oxidation and reduction. Let us take another reaction, the reaction between chlorine and potassium hydroxide. Chlorine undergo disproportionation in the alkali medium. In such reaction, the oxidation state of one and the same element, that is here chlorine, is both increased and decreased, and oxidation state increases during oxidation and the oxidation state decreases during reduction reaction. Already we have seen how to calculate the oxidation state of chlorine in potassium chlorate and potassium chloride. Here in this reaction, the oxidation state of chlorine increases from 0 to 5 in potassium chlorate and decreases to -1 in the case of potassium chloride. Already we have seen the reaction between zinc metal and copper sulfate solution. In that reaction, we have observed after some time the color of the solution disappears. This indicates that zinc displaces copper from copper sulfate solution, and we could observe a deposit on the metal strip which indicates the deposition of copper on the metal strip. Now, if we reverse the reaction by taking zinc sulfate solution in a beaker and place a copper strip, even after some time, there will be no change in the color of the solution. This shows us copper doesn't replace zinc in zinc sulfate solution. So from this we can conclude that the electron releasing tendency of zinc is higher than that of copper. We will extend this concept of electron releasing tendency and understand the concept of competition for electron transfer reaction. Competitive electron transfer reaction. Consider the reaction between copper metal and silver nitrate solution. Here in this reaction, copper replaces silver from silver nitrate. Let us understand this reaction from this picture. Place a metallic copper strip inside this beaker containing silver nitrate solution. After some time, the solution slowly turns blue. This indicates copper replaces silver from silver nitrate solution, and you could see a metallic deposit on the copper strip. This indicates the deposition of silver on this copper strip. From this reaction, we conclude that the electron releasing tendency of copper is higher when compared to silver. So in the above reaction, copper has the tendency to release electron and silver has the tendency to accept electron. We can conclude that among these three metals, namely zinc, copper and silver, the electron releasing tendency is in the following order. That is, zinc has the higher electron releasing tendency when compared to copper, and copper has the higher electron releasing tendency when compared to silver. This kind of competition for releasing electrons among various metals helps us to design galvanic cells, and we will study about the galvanic cells later. Students, let's recall all the concepts that we have discussed in this session. We have discussed about the types of redox reactions, that is combination reaction, decomposition reactions, displacement reactions, disproportionation reaction, and competitive electron transfer reaction. Hope this session was very useful to you. See you soon in the next session. Have a nice day. Thank you.